so I gotta change that light. So your test is going to be on Wednesday the 19th. Everybody will have homework due, so there will be 7 homeworks due that day. Excuse me, sorry to sneeze building. You'll have the 6 book assignments, P1, 2, 3, 4, 5, and 7. And then you will also have a review worksheet that we will give to you tomorrow or Friday, depending on when I get around to getting it done. And yeah, everybody's going to have those turned in. Okay? And we talked about enrolling in the NTC course. If you're having questions about enrolling in that course, just come find me during some off time, and we'll get you through it. Usually, if I can't solve it, because I've had almost every problem pop up so far, if I can't solve it, then we'll just quick call the NTC help desk while you're right there and get her done. Okay? So, oops. Okay, so we're going to talk about solving inequalities algebraic and graphically today. Okay, so absolute value. Okay, absolute value of 5 here could be 5, right? X could equal 5, and that is a true statement. What else could X be? Negative 5. And that still is a true statement. Okay? Now, when we go to an inequality case, that was the one we did there, was A was an equality case. When we go to an inequality case, again, X, the absolute value of X has to be bigger than 5. Logic, just thinking inside the old noggin, says, okay, so X has to be bigger than 5. Okay, so for sure, we got all those numbers, right? 7, 8, 9, 10, a billion, a cajillion, okay? 1 million, okay? All those numbers bigger than 5. Yep. Okay. But because of this A fact here, now if I think about negative 5, okay? If I think about negative 10, and I put negative 10 into that equation for X, absolute value of negative 10 is positive 10. Positive 10 is also bigger than 5. So I add in all of these numbers too. Okay? So that is the graph of that system. The inequality for that system then would be X is less, oops, tap the brakes. Let's go on top of the line. Actually, we'll go right below it. X is less than negative 5, or X is greater than positive 5. That's the inequality for that system. The interval notation for that system would be from negative infinity to negative 5, and from 5 to positive infinity, with parentheses on all of them because nothing was inclusive. Nothing had the equal sign attached to it. Okay. Now, if I flippity-floppity that inequality sign, and I go the absolute value of X is less than or equal to 5, again, I'm going to guess that I'm going to have something to do with negative 5 and positive 5. Okay? But now, if I go on the outside, so if I go like 6, if I put 6 into that equation, I get a false statement. If I put negative 6 into that equation, or not equation, sorry, I'm using the wrong terminology. If I put negative 6 into that statement, okay, I get a false positive 6, I get a false statement. But if I put 0 in there, the absolute value of 0 is 0, and 0 is less than 5. And now these would change to filled in dots because there is an equality, and it would just be in between them. The inequality statement would be negative 5 is less than or equal to x is less than or equal to positive 5. The interval statement would be bracket negative 5 to 5 and bracket again. Questions on that? Just kind of refreshing your memory about the old absolute value, and really, when in doubt, just think. Just stop and think. Try a point or try a number that's outside that range. If it works, it's part of the answer. If it doesn't, it's not. Okay? So, solving algebraically now. Okay? So when I'm solving an absolute value equation or an absolute value inequality or anything that has to do with absolute value, I am going to write the equation. I'm going to make two equations, really. I'm going to write the left side without a set of parentheses, or tap the brakes. I'm going to write the left side without the absolute value, and I'm going to set it equal to the other side, the right side. Then I'm going to write the left side without the absolute value, and I'm going to set it equal to the opposite of the right side. Okay? Now, I'm going to go through and I'm going to solve those two equations. And that's going to put my key points at 3 and at negative 2. So on a number line now, okay, those are the two numbers that I'm worried about, or that I want to focus in on. Whoa, tap the brakes. Grabbed one too far. Okay. So here now what I would do is I would test a point, or test a number, if you will, in this range. So give me a number that is smaller than negative 2. Negative 3. Okay? So negative 3 is over here on that side of negative 2. Putting negative 3 back into my original inequality. 2 times negative 3. Negative 6 minus 1. Negative 7. Absolute value of negative 7. 7. Is 7 greater than 5? Seven greater than 5. Yes, so that's true. So that's going to be part of my solution in there. That gives me a true statement. Okay? Next one. Give me a number in between negative 2 and 3. 0. Okay? 0 times 2. 0 minus 1. Absolute value. 1. Is 1 bigger than 5? Is that a true statement? No, that's false. Okay. Give me one on the bigger side of 3. 4. Okay. 4 times 2? 8 minus 1? Absolute value is 7 bigger than 5. Yes? So that's a true statement again. Okay? So open, open. We want to go that way, and we want to go that way. So that's our graph. Okay? So now writing that as an inequality, that would be x is less than -2 or x is greater than 3. Okay? Writing that as an interval, -infinity to -2, union with 3 to infinity. Okay? And those are the algebraic solutions to this problem. Okay? Same problem, just now solving it. Oops, where did that go? Wrong way. Same problem, just now solving it on the graphing calculators. Okay? Graphically now, we all have the same type of calculator. I believe that everybody can see what's going in the same color scheme that I'm going on. So I'm going to graph one side of my inequality in function number 1. I'm going to graph the other side of my inequality in function number 2. Okay? So yesterday you learned that absolute value, we can type in ABS, all that fun stuff, but there's a shortcut key, and the shortcuts are located right there. Okay? And this is the shortcut key for absolute value. Okay? And so then that was the absolute value of 2x minus 1. There is the graph of the absolute value of 2x minus 1. Okay? Then I'm going to hit tab, and I'm going to graph my right side of my equation, which in this case was 5, the right side of my inequality, as 5. Okay? So there is the right side of my inequality. Now, clearly they intersect. So I need to find those intersection points. Menu, analyze, intersection. There's 1, menu, analyze, intersection. There's 2. Okay, so there are is my graphic representation of this scenario. Okay, so this side over here is blue. This up here is red. I want to know on this graph where blue is bigger than red, where blue has a value that's bigger than red. Well, that's going to come where there's a blue, something blue, above the red, right? So that's going to be over here and over there. So we would have in inequality form, x would be less than -2, or x would be greater than 3. In interval form, we would have -infinity to -2, unioned with 3 to infinity. And those two, since this is the same problem, those two should be the same. Oops, I got an extra page in there, I guess. Okay. And those two boxes end up being the exact same thing. Okay. What I would like you to do now is, on the back side of the note sheet, there are two problems. I would like you to solve that both algebraically and graphically. I'll give you about 6 or 7 minutes to get that done, because the graphic should take a lot quicker than the algebraic. Algebraic-wise, on this one, I would go I would go x minus 5 divided by 4 equals 6, and I would go x minus 5 divided by 4 equals negative 6. Okay, multiply both sides by 4. X minus 5 equals 24. X minus 5 equals negative 24. Add 5. And that gives me x here equals 29, and x here equals negative 19. So, on my old number line, I'm worried about negative 19, and I'm worried about positive 29. Something to the left of negative 19, I'm going to go with negative 23. Now you may be saying to yourself, why is Linsmeyer choosing negative 23? But negative 23 minus 5 is negative 28. Negative 28 divided by 4 is negative 7. Absolute value of negative 7 is 7. And is 7 less than or equal to 6? No, that is a falsitude. Okay? I want to go with 0 in the middle, but I'm not going to. I'm going to go with 1 in the middle. 1 minus 5 is negative 4. Negative 4 divided by 4 is negative 1. Absolute value is 1. And 1 is less than or equal to 6. I'm going to go with 33 up here. 33 minus 5 is 28. Divided by 4 is 7. Absolute value of 7 is 7. And 7 is not less than or equal to 6. So I've got filled in dots now because of the greater than or equal to portion. And then I got there. Okay? So inequality-wise, this one would be negative 19 is less than or equal to x is less than or equal to positive 29. Interval-wise, negative 19 with a bracket, 29 with a bracket. Okay. Graphically, this one would be absolute value of x minus 5 and 4. And my other one would be, what was the other one? 6?
Yes.
There it is. There it is. Menu. Geometry. Points and lines, I think it is. Intersection points. because I wanted to know where it was less than now, so I'm looking for where blue is below red. Okay? Next, okay, so since it's equal to 0, I can't really go negative 0 and positive 0, so I'm just going to go x squared minus 3x minus 10 equals 0. And I'm going to say to myself, well, that factors to be x minus 5 and x plus 2. So then x minus 5 is going to equal 0, and x plus 2 is going to equal 0. And then I'm going to add 5, and I'm going to subtract 2. And I'm going to say that x here has to be 5, and x here has to be negative 2. Okay? So those are my two numbers that I'm looking at on my number line. Okay? If I plug in something over here, I'm going to go with negative 3. Negative 3 squared is 9. 3 times negative 3 is negative 9. Positive 9 minus negative 9 is 18. Minus 10 is 8. 8 is greater than 0. So that's true down there. If I go with 0 in here, 0 minus 10 is negative 10. And negative 10 is not greater than 0, so that's false. And if I go with 6 out here, 36 minus 18 is 18, minus 10 is 8, and 8 is greater than 0 again. Because I'm dealing with just a greater than, we've got open dots going that way and that way. And so again, the inequality statement would be x is less than negative 2 or x is greater than 5. Negative infinity to negative 2, 5 to infinity. We got that. Okay. Graphically, x squared minus 3x minus 10. There it is. Now here on this one, because it was 0 on the other side, I can just analyze my graph for the zeros. I don't even need to put in that other 0, or put in the other function, if you will, as a 0. So because it was greater than 0, I'm looking for where it's above the x-axis. Okay? Good. The other part of today is we are going to be taking a formative assessment here in the last 17 minutes or so. So if you wanted to clear off, we're good to go.